Anyone has any question from past session? Last day we learned about different file formats, and today we will be installing one software related to file format conversion, and it is universally used named as OpenBabel. Next I will start with structure comparison. So if anyone has any doubt, please let me know. In the last session I discussed about different file formats like PDB, PDBQT, MOL2, MOL and HDF file formats, and we will be going in depth if required when they are needed. So today we will just install OpenBabel. So I will request everyone to follow me. Visit OpenBabel on your system, openbabel.org, and download the package according to your requirement. I am also following along with you people. So from here I will go to download, and I am using Windows, and if you are using other system, then go there and you will get software according to your requirement. And I will click on the latest installer option here. And last time many people were having problem about 32-bit and 64-bit. So uh, choose choose version according to your system. Here I am using 64-bit .exe file, and this I guess this one is 32-bit. So you can, those who are having 32-bit system can use this option. Let the installation run in background. Meanwhile I will explain why do we need this OpenBabel and what is the purpose of installing this software. And when you are able to install, it will look something like this on your system, and let it run on background, and if you face any problem, let me know. Basically yesterday we saw that there are multiple file formats where we need to use different file format for different software, and basically I also I also explained why do we need different file formats like ABC PDB file format and PDBQT, then MOL2, mol file format and SDF file format, and then smiles or inch key. So this PDB and PDB, all these file formats have same information, like composition of atoms, and if they are further aggregating or grouping atoms, then they will group it as a residue. And later on, and more complex, in PDB format we saw that those residues are grouped as chains, and a software or any software or package treat a group as a model. And in Chimera X or PyMol, you will be seeing multiple, if there are multiple files, you will be dealing them, interacting them individually using some uh, options on your system. So in PDB file or any other file, you have seen that there is composition of atoms, and atoms, for the atom property there is atomic name and their coordinates, and sometimes charges, and also there is information about bonds. This information varies from software to software, like atomic name. Atomic name is compulsory in mostly present in all the packages, but you might be missing coordinate information, like we see in smiles file. Charges information was missing from PDB file, and bonds information may not be present in PDB file, and you have seen bond information was present in mol and SDF file formats, and there and similar, but it was missing in smiles file format. So these packages, sorry, these file formats have this information as per their requirement or their structure. So to convert from PDB to PDBQT, or PDB to smiles, or smiles to PDB, we need a package, and that package is OpenBabel. So think it as there are two people who have different languages, like if one person knows German and another knows English. So to understand each other, either one German speaking person will need to translate English into German to understand it, and English speaking person will need to translate the German in its native in its native language. So for that purpose, here we have package OpenBabel, which converts one file format to another file format, and which is required by some particular package. So over the time we will be requiring this to interact with different softwares. uh, Today we will be just installing OpenBabel. There nothing, we don't have to do anything, just keep it installed on your system. Next we are going to compare structures. I have one question. Suppose you have one residue, random residue is given, residue 1 and residue 2. How will you know that these two residues or amino acids are same or different? What will be your approach? Can anyone answer me?
Sir, can you please repeat the question, please, for once?
My question is, suppose you are given two files, where with the residue information only. So there in one file there is residue information residue 1 and second one has residue 2, just for simplicity. So how can you compare those two residues? Like I have given you two serine residue. How can you confirm that both of them are serine?
So similarity of the arrangement of the amino acids.
Uh, it is single amino acid, so how are you going to compare it? Because we can compare similar attributes. So to compare the similarity between two residues or two structure, first we need to see what information is present in the residue. First we will be seeing atoms, so we can compare atoms, means what atom is present in residue 1 and what atom is present absent in residue 2. So based on that comparison we can uh, come to conclusion that residue 1 has these many atoms and residue 2 is missing those atoms. So based on that we can find the similarity. Now next could be next could be their three-dimensional conformation. Like residue 1 might be having might be present in water or has been determined using some other uh, solvent. So the bond angle and bond length will be bond angles will be differing, means the relaxed form of residue 1 and residue 2 in a protein might be different. So for the comparison we can do, we can follow multiple approaches. Like we can go for the sequence in a if we are comparing a protein, first we can compare sequence, then we can compare the three-dimensional coordinates of those sequences. So uh, for a simple example, if I talk about two atoms, atom 1 and atom 2. So if we know the element name, we know that two atoms are same, and if they have any charge, then based on that charge we can differentiate that one atom is charged or uncharged. If they or if they have lost some electron or gained some electron to bring change in their charges. So based on that we can compare atoms, then we can compare residues, and later on we can compare a whole molecule like DNA, RNA or protein. So for DNA, RNA and protein comparison we need to know their sequences. So first we can make comparison based on their sequences, and for sequence comparison you might be knowing about BLAST or FASTA or BLAST alignment type tools. FASTA, FAST and FASTP is like that, means alignment tool. So and later we can compare their three-dimensional structure. So for 3D structure comparison I would try to take some example. Like if we want to compare two shapes or two 3D objects, like if we want to compare two pens, then what we can do, we can either superimpose them or know their height, width or their dimensions, then we can compare. And so like that we need to find some attribute by which we can compare them. So one to compare the molecule in silico, since in silico molecules are simulated, so we can superimpose molecules in silico experiments, and in vitro experiments to find that there two proteins are almost similar, we perform gel electrophoresis, and based on ladder or their movement in the gel electrophoresis we can find we understand that these two proteins have same molecular weight or same properties which made them to align come to the uh, which made them to travel same distance. So here I am taking one example of residue. Yesterday we extracted two leucine residue, and today I will compare those two residue here, and also try other examples as well. I am opening these two residues by directly drag and drop, and to visualize them we can view all, and I will use right mouse to move one model. So what is superimposition? That if I move this molecule and uh, bring it to this position, means first molecule's position, then I can know that how equal these two are, means how similar these two are. So for that I can use drag model option here, and by pressing right click I can move it. So, and I need to rearrange it by rotating like something like this. So like that we can check if those two are similar. There are options, I will tell you that as well.
Sir, can you please share these residues in Telegram so that I can also copy that in the same time?
Yes, sure, sure, I'm sharing it. This is example from last session, and earlier I have told you about how you can extract residues. So like this we can superimpose and check it. So we can see that the element, I will change its representation, and for that I will unselect all, and so this, and ball and stick, yes, ball and stick model. So here we can see that it is uh, carbon, and I will name all these elements by using label. Select, sorry, action, label, atom, name. So here I am seeing that these two residues are carbon, sorry, these two atoms are carbon atoms, this one and this one are carbon atoms, and are almost at same position. Here oxygen is present and carbon is present, and here nitrogen. So it is kind of superimposing, but arrangement is bit different. Like if we see at this position, I will try to superimpose it again. State model. I guess if I correctly superimpose it, then even then there will be some difference here. Like it has some difference in bond angle, means, or it is a bit having some difference in its angle, means rotation. So like that we can superimpose, and to perform the same action there are commands here, and to use that command I will use align option, align command. ALIGN, and here we are seeing two models, model id 1, so I will use model id 1 2 mod model id 2. So how does this command work? I will use align keyword, it is command, and then model which is going to be aligned to another model. So keyword the connector will be 2 and then model 2 or other model to which we want to perform the alignment. So using this option, means this command, we can perform the alignment option. I will use this command to align model 1 to model 2. ALIGN space has 1 2 has 2. So it will superimpose both the models. And here if we see closely, then we can observe that there are some differences, because both of these residues are from different chains or different position of same protein, and they are having different conformation. One thing you might be understanding that bond angle and bond angle or relaxed, any relaxed molecule has position based on its environment, based on thermodynamics or entropy. So due to that effect, different residues having same composition may be having bit different arrangement of atoms. So like that I can check that these two residues are different. And next thing is that we can calculate the difference in their difference in atom distance. So let us suppose I will change its molecular display again, and ball and stick. So I am making it a bit away so that I can make it clearly understand. Right mouse, drag model, and if I move it here, so like that if we see that this atom is, these two atom oxygen atoms are different distant from each other, and carbon are away from each other. So for, and this distance can be calculated for each and every atom. And uh, the distance currently here will be yes, Bhupendra, are you saying anything?
Yes,
Yes sir.
sir. How you separate them in a single? Because I am unable to separate them like you.
Okay, what I did is first I selected residue 2 or residue 1, then I went to right mouse click, right mouse option here. If you are using Chimera X, you should see this ribbon. Actually this I the important thing is alignment has 1 to has 2. Remaining things I am demonstrating to make you understand. So if you go to right mouse and see drag model or other options here, move model, drag model or drag atoms, you can perform the actions like I have done.
Yes, yes.
Okay,
Thank you.
so here we can calculate the distance. So there should be some option here. Okay, so I will use this tape and try to draw here. So here we can see that these two atoms are separated, and similarly here carbon are separated and having some distance of 1 Armstrong, and here again carbon and carbon are separated. So like that all the atoms are separated from each other. And if we see a protein, means we want to compare to protein structure, then this count will rise significantly. So here we can say that there are 5 atoms and they are separated with some distance of 1 Armstrong or 1.03, something like that. So we can tell this value in a average, and that average is that average or particular term is root mean square deviation. So this molecule is deviated from this molecule with some distance, and that distance is calculated by squaring squaring all the distances and getting their mean, and getting the under root of that final value. So that is called root mean square deviation. So root mean square deviation tells us that how much one molecule is varying from other molecule. If distance is very nominal, then that means molecule is very similar, RMSD value will be very low. So RMSD is calculated as first distances, then their means, their squares, then their means, and root value. That will be known as RMSD. So all the distances will tell you some RMSD value. That RMSD value will let you easily understand how two molecules are different. So I will close this model and reopen these two again, and use the same align command to align these two, and molecular display graphics view all. And here if we see this thing, log panel, then we can see some value here. It's currently it's showing, for me it's showing 0.132. if you are using some other residue, then you will see different value. So this means these two models are quite are similar to each other, because this value is very low. Over the time you will be practicing and comparing more proteins, then you will understand that how does a lower value is significant, means tells you that two structures are similar, and higher RMSD value will tell you that two structures are quite different. So and now I will take other example. uh, Means both these examples are different, and I will load here view. So these two there are 4 residues currently, and I will hide earlier one. I need to delete 4. So I have opened 2 random residues, uh, one for from earlier example, and next one from another example. I am not telling the name. So I can align these two using this model ID, as I have already told you. Here I am going to compare model 2 with model 3. So to compare model 2 with model 3, I will use ALIGN 2 3. So these two will be aligned here, overlap with each other, and we can see them here. So here we can see that these two residues are also same. So and again here RMSD value is 0.165. So this is less than 0. So the atoms in these residues are quite closer to each other, and that means these residues are quite similar. I will extract other example from other file. I am taking this residue one. Okay, I am deleting other residues. Now I have model 3 and model 4 for comparison. Model 3 and model 4 for comparison. I will compare them using align command. ALIGN has 3 2 4. The command I am typing is ALIGL, and my model is 3, so I have typed 3 and taking it to near model 4, so I am using the spacer keyword and there and used hash 4 to tell it that it is model ID. Earlier I have told you about the documentation of Chimera X, where this hash symbol tells you about selection of model ID. So I will view all. Now here I am seeing that RMSD value between 8 atoms is 1.29. So earlier the difference was 0.1 something, so those were quite overlapping, and now this value is very higher. So this higher value is telling us that these two molecules are quite different. Although these two residues are similar or same, but due to their position in protein and their environment, these these two have acquired different rotations. Their carbon carbon bond has acquired different rotations, so they are bit different. So this was a comparison about residues to make you simply understand what is RMSD, or how two molecules can be compared. Now let's take similar example, and for that I am I will try to navigate to RCSB where I will try to get some multimer. So to find the multimer, I will directly type uh, hemoglobin is multimer or monomer. Can anyone tell me about some multimer molecule? Means there are more than one monomer units in same protein structure.
Sir, I think multimer.
Which protein? Can you name the protein? I couldn't heard clearly. I would suggest everyone to speak. I don't have good communication skills, but that's why you people should be encouraged now. Tell me some
I
protein.
think she said multimer.
Uh, Multimer is the keyword. Means if there are multiple monomeric units, then it's multimer. I want to know about
Yes, sir.
protein
Yes,
name.
sir. Multimer, polymer. Yes, sir.
So
But
which
don't know
protein?
if she.
Any protein do you know about that is multimer, that has multimeric units, means multiple monomeric units in its structure? You can comment in Telegram. I will check that. Crystal structure of Barnett Couch. Okay, so this might be having multiple structures. I am taking this protein and will check if it has multiple proteins. Sorry, multiple units.
Sir, microtubules.
Microtubules. Okay. So let me check if I can get one. Okay, so I will take this example. Um, can anyone tell me how, if I want to know how many chains are in here, any way can get the number of chains in this protein structure? um, how can I select know the number of chains in this structure? Okay, select chains, alpha
So
chain.
let's say select chain. There you get.
Okay, thank you. And beta chain. So there are 4 chains here, and I will select one chain like this. And I want to separate these chains. How can I do that? Oh,
Show only or hide option.
what?
Sir, select in that selection structure. They have the second side chain plus connector.
Okay.
Mm.
In this
Yeah.
structure, right?
Yeah, yes, select then structure section. After that, there are the options like side chains, connector, and side chain only.
Okay. I can also select using chain and hemoglobin chain. I have done that. Means I am able to select a chain, but I want to separate these two structure and get different model IDs here. Currently, this is single structure. I want to check that it is a multimeric protein. So all these chains are same or different. That I want to check. So can you tell me how can I separate these two structures? Means I want to
Action
separate
show
A and
only
action.
action
Huh?
atoms and bonds show only
Mm,
atoms and bonds.
okay, actually I this see this is a protein and there are chain A protein and currently it is loaded as model 1. Fine. Now and has chain A, B, C and D. I want to save it as a.pdb, save it as b.pdb. So I want to separate all these chains so that I can compare all these structures separately. So how can I do that? Okay, so I have not explained about saving structures from Chimera X, and I would suggest to practice that using save command, which you might have already tried. And if I use save option, I can save these structures on my system.
So these selected only will get saved.
Yes, uh, I guess I am still making some chain A, save displayed items, save selected items only. I will save chain A dot pdb. It is saved. I will select C now. C chain is selected and go to file, press save, and I will again copy the path of folder and save it as chain B dot pdb and save selected only and to the save option. So I have saved two chains, chain A and chain C. Now I want to check if those two chains are similar or different. I will open those chains separately and put here. So I have two chains separately and I am also getting two model IDs, model 1 and model 2. So using align command I can align them. See, there is one more option, matchmaking something. We will be exploring that later, but currently we just want to know if two structures are same, then align command will not produce any error and it can help you easily align two set of atoms or two models. ALIGN has 1 2 has 2 and those two chains are means perfectly overlapping, chain A and chain C. Here if I see the log, it has some information. chain A and chain C, and I am able to overlap those two structures, and they are quite similar to each other. There is a bit difference, so there should be some RMSD value of there is RMSD value of 1.159 Armstrong. So earlier we saw that two residues were having less than 0 because there were less number of atoms in a residue comparison while we were comparing residues, but here there are multiple atoms, and um, the statistical value or RMSD value will be bit higher. So here RMSD value is higher, but these higher than the residue one, and here those two chains are almost similar, and RMSD value is low, root mean square deviation value. Now I will open some other protein and check if those two chains are similar. I am going to
Sir.
yes. Yes, you were saying something.
Yes, sir. Sir, in Chimera, not Chimera X, it's Chimera, sir. How can I like search this value, like deviation value and these things? See, sir, whatever you are doing in your Chimera X,
Yes.
but I don't know, sir, which options choose for only Chimera. So,
Okay.
like, it is like very. And sir, like if I choose one structure first,
Give
and
me
then
1 minute.
if I
Give me one
yes, sir.
minute. I am also demonstrating you on the camera X with some other example. Okay.
Okay, sir. Okay, okay,
Okay. So I am
okay.
opening another protein, and I want to save its some other chain so that you can see how two very different chains will have RMSD value. So here I am opening this one, and here I will select this chain A. Chain A is selected, and I will use file menu, save, PDB file, chain protein 2 chain A something. I'm not distinctly saving these values just because I'm focusing that how you can compare chains only. So I have two different chains now, and I will close other structures, open by drag and drop, and view all. So these two chains are here, and now I want to compare chain 1 with chain 2. Align option, align as 1 2 as 2. So it's telling that there are unequal number of pairs. So this error is due to that they are entirely different structures, and there none of the atoms or sequences matching. So due to that reason, these two are having these two structures are not being able to compared. So for that, what I can do is I will try to find some protein. If we search for a protein on PDB, we get similar structures, but those similar structures out of, like, if we get two structures, structure 1 and structure 2, then the difference between those two structures could be that structure 1 might be having some uh, more residues, and 2 might be missing some residues. So due to that reason, where we can perform this comparison easily, but here the sequence is entirely different for these two chains. Earlier we saw that from a multimeric unit we took two examples, two chains, and all the two chains were having same structure, means same composition, so they were easily compared and we got an RMSD value. So like that we to compare we can compare two similar chains, and for that I am going to take another example and I will try it in UCCF Chimera. Command line. Chain A, and chain B. So these two chains are open, and now I can use ALIGN command. Hash1 to hash2.
Sir, how to separate two different chain with different PDB number?
To separate two chains, we can like here two chains from two. Can you repeat your question?
Sir, and my question is, sir, how to separate different chain with different PDB number? You are like you are extracting two different chain, na chain A, chain B.
Yes, from same PDB I am doing that. I will explain this chimera one later, because I need to go through it once. So I am just
Okay, sir. Okay, sir.
yes, I am taking
Okay,
example
sir.
of
Sure, sir.
hemoglobin. I am
Okay, sir.
opening this one protein, open one protein and another same protein, so that they have similar sequence. One protein is open and another protein I am opening. So this protein has these many of chains, chain A to O, and here we are seeing that chain A to H are there. So I will compare chain A from uh, structure 1, model 1. So I have selected chain 1 and saving it as uh, saving it as chain 1 here, using save option. File name, save selected item, and example 2, chain example 2, structure 1, chain 1, chain A. So first example is saved, and I will take example from second model, 1HV4, and I have selected its so I'm going to save it again. I'm taking from structure 2 and saved it. I will close older models and take these two chains Okay, so these two chains are uh, from two different structures are before us. Hide, so cartoon only. So these two are overlapping. And again it has multiple structures in chain A as well. So I am hiding one for now. So this is from model 2, and sorry, I will hide it using this option, and this part is from model 1. So I need to compare these two models. So to compare these two models, need to show them all. Okay, I will restart it because it might be confusing. So after saving both the chains, I have opened them and used view all option, or I can simply type view to view it all. Now I will change its display so that I can easily visualize it. So these two protein chains are visible to us, and from the model I will collapse these things, because as I already told that there might be multiple groups or subgroups here within a model or structure. So you are seeing that currently. If I hide structure 1, so structure 2 is here, model 1 is here, and model 2 is here. So these two structures are almost similar, and structure 2 has more atoms than structure 1. So still we can compare because they are having some similarity. So I will use align command again, 1 2 hash 2, again unequal number. Okay, I am not able to perform it right now, otherwise it is going to kill more time. So basically I want to make you understand a few simple things. First we were comparing residue using align command, where similar residues with this similar composition, atom composition, has been compared, and we got RMSD value. And then we compared chains using align command, and there should be also similar residues or similar sequence to compare, otherwise it was giving us some error. So here we have compared two residues and two chains. So this much is enough for this session. I would request people who were facing issue after this session, so that I can demonstrate and show you how you can hit and try to get these things done. Basically the two working examples were sufficient for this session, where you were able to see two residues were compared or two chains from same proteins were compared.
Okay, sir.
From this two limited examples or two basic examples, everything, any question?
Sir, actually, I am facing the issue right now that from the from one molecule, that like hemoglobin,
Yes.
how can I separate these two segments differently? Like you are saving somewhere, I'm unable to do that.
Okay.
Can you explain me
Can you
that
can you
from the
share
one
your screen?
molecule?
Can you share a screen,
Yeah, sure, sir.
please?
Is it visible, sir?
Uh, no, it's not visible. Are you able to share or not? You are able to share your screen, right?
Yes, it is visible because in the section of share, it is not allowing us.
Not allowing us. 1 second. Activities, people, water. Give me 1 second. Host control. Can you share your screen now? Check once.
No, sir. The share option after the selecting the share now, then the another slide open up. In that the only cancel button is blue and the share option is not.
Okay. So, can anyone else try sharing their screen?
Yes, sir. Sir, I'm trying.
Yes, sir. Vasu, Vasu, are you not able to share your screen?
Yes, sir. I'm sharing it, sir. I think I shared.
Yeah, you are able to share. I guess he had some other problem, maybe.
Yes, sir. Yes, sir. I think. So, sir, if I shared my screen, then I will show it. My like I'm. See, sir, I was doing a residue.
Yes.
Uh, I'm opening your residue one. Opened. Now, sir, if I open the next residue, like it can open here only, na?
Yes, you should try once now, even if you
Sir,
fail.
I opened, but it is not opening, sir.
Okay,
See,
it is opening. Wait.
It scroll down, please.
In the command line, type view.
in the command line,
Type no Chimera command. In Chimera command, type view.
okay, sir.
VEW.
Sir, chimera command here, na? This open, right, is
Yes,
open.
exactly here.
What I write, sir, here?
VIEU.
I
VIEW. View.
view.
View. Is it working? Not working.
Please specify input file name and type.
It's closed. If you use control and drag, then it will zoom out and you can view all the
Control
molecules.
and drag.
Yes. Next, control and scroll. Sorry, control and scroll.
Control and scroll.
Yes.
Uh,
I have closed.
mm,
It's not working. Okay.
mm,
Try through tools. Vasu, what I am suggesting is I need to go through all these things once myself because
okay, sir. Okay,
then
sir.
I will share the solution with you.
Okay, sir. Sure, sir.
Okay.
No issues.
Vasu, are you sharing? Who is going to share next screen?
So myself,
Okay,
Bhupender Sahu.
Bhupendra, sir.
The same issue right now. Chrome want to share the content on the screen.
I think you have some issues in your
Yes.
laptop.
Sir, I am again joining the.
Yes, sir. Please try again. Gopi, yes, please.
Sir,
Yes,
excuse me, sir. Sir,
yes.
like, can we change our laptop from 32 bits to 64 bits? Is there any
Actually,
such type
that
of?
that's hardware thing, like your computer's motherboard, RAM, and cables. So you can't you have to replace the system.
Okay.
And recent all the software and hardware are working with 64-bit only. So try to adjust and try to find
Okay,
out
sir.
solutions.
Okay, sir.
Gopinath was asking some question. To superimpose, I told you about align command for now, and later on we will be using matchmaking or some other commands to exactly overlap two structures and compare their attributes. Other than RMSD value, we will be trying to find out other things. Okay, so you have four proteins, sorry, two protein one model protein, and it has A, C, E, G, A to H chains. Okay, so to save one, what you can do is go to select, go to select, and there.
Yes, sir. It's now.
Okay, go to select and select one chain. Select
Yes, sir.
chains A,
So,
from chain A. Select some chain A.
chain. Okay, sir.
Okay,
Yes.
chain A, and from file menu,
File menu. Yes.
save option,
Yes, sir.
and here you need, here, yeah, navigate to the directory where you want to save it.
Okay, sir.
That will be under users, or directly copy the, yeah, okay, in documents it will work. I would suggest to create a new folder.
Okay, sir. Mm, docking. No. In. File name, sir. It's blank.
No, you give some file name, go get inside the folder, HEMA, get inside the folder and type some file name. You are not getting that option of save as. um, do one thing,
Yes,
uh,
sir.
in the lookin option, can you copy this path, D drive, and I guess you have clicked on wrong option.
Okay,
And
sir. I will cross that. Okay.
okay,
I will again do this. File and save as. Save actually.
yeah, use save option.
Yes, sir. Control save. This.
Okay, include map. It's showing means like me. Okay, change the files of type to PDB.
Uh, File type to PDB. Okay, sir. Um,
It should be,
PDB.
yeah, it's just below your cursor. Three, yes,
Yes, sir.
yes, dot
Hmm.
PDB. Okay,
Okay, sir.
so okay,
Let me just locate that.
HEMA
He. Yes, sir.
chain A, give
Yes.
it some name.
Yes. Save.
Wait, chain A, and here you are seeing that there is a option save selected atoms only.
Where, sir? Sorry.
Save selected atoms. Yep.
Oh, yes, yes, yes,
Yes.
sir.
So using this save selected atoms, you can save protein chain 1, chain A. So you should give your file name chain A because you are ignoring
Okay,
other
sir.
atoms. So if you give it chain A, you can easily distinguish it. Okay. So you have chain A now, and you
Mm,
can, if you save it, you will
mm.
get chain A saved in your file. Other
Okay,
things
sir.
will be removed.
Okay, okay, sir. For the next, I will go to the again
Chain,
the chain and
select chain, other chain.
chain C. Yes, sir. And the file save. Um, I think so. Uh, chain C and this. Yes, same, sir.
Yes, yes.
Yes. Okay, sir. Okay, okay.
Okay, now you can
Uh,
use, can you do close option and load those two files.
okay, sir.
Drag and drop those two files. आराम से. Okay, now you have two chains here. Now use
Yes.
align command.
Align. Okay, okay, sir. I got align. X. Align hash 1 2 hash 2. Yes, sir.
Okay, so these two are aligning, and you can see that there is RMSD of 0.030.
Yes,
So
yes.
these two
Similar.
structures are very much similar to each other.
Okay. Yes.
Okay,
Thank you, sir.
there are other options, and one more thing. Click on
Yes.
align option where you are seeing RMSD. Click on
Uh,
align.
okay, align. Okay.
So you will see the documentation of this align command here. Okay, so you can see other options here. Maybe based on your requirement you can find one appropriate option, but this basic example should help you understand how you can superimpose two structures. And I guess this also answers the question of Gopinath.
Yes.
Yes, yes, sir. Yes, sir.
Any other question or any other problem to perform these basic examples?
No, sir. Thank you, sir.
Okay, I have already explained why do we need to convert two files, but while performing docking and other molecular dynamic simulation, we will understand it by doing hands-on. And in the next session, we will be starting with Autodoc Vina, but before that, we need to prepare molecules using this OpenBabel, and we are going to install one more tool that I will explain. So mostly uh, by the end of next week or after 1 week we will be able to start with docking at least, and there then analysis part will be quite simple because I have already explained you most of the things like RMSD or what are the coordinates or file structures and how two atoms interact. So you will be understanding those things quite easily. Okay, bro. Meet in the next session. Any other question from anyone?
Sir, can you please share link for the Open Babel for 32 bits
Uh,
in the Telegram?
yes, sure. I will share. Actually, if you go there, I will share it. I will share it. Don't worry. I'm sharing. Okay, so I'm ending the session, and if anyone has any question, please share it in Telegram. Thank you. Good night, everyone.
Okay, sir. Okay. Thank you, sir. Good night.
And who has any problem can stay in the meeting so that I can guide them